Lesson 79, Factoring Trinomials by Using Greatest Common Factor. One thing that I like about this lesson is it comes shortly after our other lessons of factoring trinomials. So it's another lesson to give us more practice of doing those same things that we've been doing. We're going to use some of those same concepts. So it says, to factor trinomials completely, we need to begin by factoring out the greatest common factor, or GCF. So what we're talking about here is we're going to do factoring. The first step that we do is going to be the type of factoring that we used to do in the old days whenever all we were doing was factoring out the greatest common factor. So we're going to start by doing that. So on example 1, we are going to factor out the greatest common factor of these three terms. So the biggest thing that I can factor out of all of them is that a to the third there. I can take an a to the third out of each of them. So if I take out a to the third, I'm left with a squared plus 3a plus 18. So now I can use my old trinomial rules of something that multiplies to get 18 but adds to get 3, okay, because I have a 1 in that lead coefficient spot. So I'm going to have a to the third, and I'm going to set up my parentheses. That a squared I'm going to split here. Then I need to find this, also I can go ahead and say, since both of these are positive, both of these have to be positive. So things that multiply to get 18 are 1 and 18, 2 and 9, 3 and 6. Of those, do I have the sign wrong somewhere? Shoot, I do. This is a negative, so this should still be a negative. I apologize, which means that one of these has to be negative and one of them has to be positive. Let me fix that really quick. You can tell very quickly, notice how I had made a mistake because none of these were going to get me the 3 that I needed. At least not with both of them being positive. So I knew immediately I'd missed a sign. That was my bad. I'm sorry. So now what we're going to do is which one of them needs to be positive? Well, we look at this sign. This sign's positive, which means we want the bigger one to be positive. So I want 6 to be positive, 3 to be negative. Final answer. On this one, my greatest common factor for this problem is going to be 2 because they're all even, so I can take a 2 out. I can also take out m to the second. So if I take out 2m to the second, I'm left with m to the second minus 16 divided by 2 is 8, m to the third divided by m to the second is m, plus 30 divided by 2 is 15, m to the second divided by m to the second is 1, so I don't need to show that. Again, I have a coefficient of 1, so I need something that multiplies to get this and adds to get this. So I have 2m squared. I'm going to set up my 2 sets of parentheses. Split up that m. If I have a positive here and a negative here, that means that I have to have something that multiplies to get a positive, but adds to get a negative, which means they both have to be negatives. So things that multiply to get 15 are 1 and 15, 3 and 5. Of those, I can get an 8 out of 3 and 5. Since they're both negative, it doesn't matter where I put them. And that's my final answer. Same thing here. Okay, I can take a d out of each of these. I also want to point out that we've talked how we don't want to have this negative, so I'm actually going to factor out negative d. When I do that, I'm left with d squared, because the negative came out. If I factor a negative out of a positive, this becomes a negative, 7d. Negative comes out, so this is now a positive 6, that d is out. So I have a coefficient of 1. I can go ahead and split up my parentheses. My d squared splits. I need something that multiplies to get 6 and adds to get a negative 7. I'm in the same situation I was on the last problem. To multiply to get a negative and add to multiply to get a positive and add to get a negative, they both have to be negative. So things that multiply to get 6 are 2 and 3, 1 and 6. 1 and 6 is going to get me that 7. They're both negative. It doesn't matter where they go. Final answer. On B, same thing here. I have a negative in front, and I don't want that, so I'm going to factor out a negative for sure. I can factor 5 out of each of the coefficients, and I can take a y to the first out of each of them. So that is going to give me y to the second, because it's positive now, plus 5y, plus, okay, my signs are all changing, 4. I have a coefficient of 1 here, so I can take negative 5y and split up those parentheses. So I have y and y. These are both positive, so these are both positive. I need something that multiplies to get 4, but adds to get 5. So I have 1 and 4, 2 and 4. So 1 and 4 will get me 5, and I'm going to place them right there. On example 3, it wants us to factor completely, so I'm going to look at what I can take out of each term. I see I have p to the first in each term, so I'm going to factor out a p. I have q, 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 and I can take a q squared out of each of them, so I'm going to do that. If I take p, q squared out of the first term, I'm left with q squared. Out of the second term, I have plus 5. The p came out, q is now to the first, minus 14, the p and the q squared came out. So I have p, q squared, and I'm going to set up my two sets of parentheses. I'm going to split up that q squared, and I know I'm looking for something that multiplies to get 14, a negative 14, but will add to get a positive 5. So things that multiply to get 14 are 1 and 14, 2 and 7. 2 and 7 I can get a 5 from. I know because this is negative, I have to have one positive and one negative. Because this one is positive, the bigger number has to be positive. So 7 is going to be positive, 2 will be negative. That is my final answer. On B, okay, I'm going to get you started on this one, and then I'm going to have you finish it on your own. So what can I factor out of each of these? I can see that I can factor 3 out. Each of these is divisible by 3. I have A. I can take a to the first out of each of them, and then b, I can take the b out of each of them, which leaves me with, in the first term, a squared minus 4, because I divided by 3. One of the a's came out, so I just have a, minus 15 divided by 3 is 5, and then the a and the b came out. So I want you to finish this one on your own. On this one, I can factor a 2 out of each of these. So I factor out a 2. I have m. I don't have an m on that one, so the m's won't come out. N, so I can factor out an n. When I do that, I'm left with m squared plus, if I factor, or if I divide 48 by 2, I get 24. The n came out, minus 22 divided by 2 is 11. I have an n that came out. This m is here. Now I'm going to reorder these. So I have m squared minus 11m plus 24. Okay, I have to have it in standard form so that I can factor it. 2n, and then I'm going to split up my m squared to two sets of parentheses. I need something that multiplies to get 24, but adds to get negative 11. Now, for that to happen, for me to get a positive here and a negative here, remember, the only way I can multiply to get a positive is if I have two positives or two negatives. Since I need a negative here, it's going to have to be two negatives. So things that multiply to get 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. 3 and 11, or 3 and 8 will get me that 11. So I put 3 and 8. Final answer. The number of feet a rubber ball falls in t seconds is equal to 16t squared. 5 seconds after Sid lets go of a rubber ball, Sally lets one go. For her experiment, the distance fallen in terms of Sid's time is 16t squared plus 160t plus 400. Factor this expression completely. Guess what I want you to do on your own paper? I want you to give that your best shot. I really think that you can do it. Refer back to the other examples that we did so that you have an idea of what you need to do. Make sure that you factor out the largest number possible from each of those, your greatest common factor, before you try and actually split up that trinomial. So that's all I have for you. I hope that you've taken good notes and that you have a good night. I'll see you in class tomorrow.